Welcome back to This Is Fine, the podcast where we candidly discuss tech, government, and the enterprise. I'm your host, Matt Triner, the CEO of Hunter Strategy. In this episode, we take a deep look into the wild world of cybersecurity challenges in Internet of Things, or IoT devices. As we navigate this jungle, our special guest is none other than Adeel Chohan, a partner solutions architect at AWS and longtime subject matter expert in the field of IoT. He has developed IoT-driven AI solutions for the world's top corporations, including leaders in the EV sector, media, and entertainment industries, as well as robotics. So buckle up and get ready for an enlightening and entertaining conversation as we dissect the complexities of IoT device security with a dash of wit and wisdom. Without further ado, let's jump into the chaos and declare that this is fine. Welcome, Adeel. Great to see you.
Thanks for having me, Matt.
So just to kind of explain, because I think when people think IoT devices, they're really thinking smart homes, things that they can kind of touch and feel that are a little bit more simplistic. You're obviously doing this for AWS. I'm sure their market is not focused on smart homes. So from your perspective, what does IoT devices really cover? What would people not think about when they think of IoT devices that kind of help people kind of get on the same page for this discussion?
Yeah. And I think the term IoT kind of has now been loosely used to describe a large set of devices. I think in the consumer space, we oftentimes relate it to things like a smart light bulb or automatic garage door opener. But in reality, IoT devices are everywhere, even before IoT was called IoT. And where we see non-traditional use cases of IoT, that really comes in from any device that is basically a physical object that can connect to a local network or the internet to communicate, collect, and receive data. Typically, these devices are sensors that collect some sort of information and perform some sort of action. You can imagine in the healthcare industry, you have an X-ray machine that Boston Scientific has, for instance. All those machines probably have some sort of smart features in order to communicate this information back to the doctor's office or so on and so forth. So that then in turn become an IoT device. We also see that a lot across the industrial space. When we look at the manufacturing facilities, when we take a look at power plants, when we look at wind turbines, when we look at critical infrastructure. If there's a way to remotely control that device, even within the local network, that becomes an IoT device. So it's a lot more than just your typical home automation. And generally, I don't even like to categorize it into these vertical categories, because essentially nowadays everything that we have is an IoT device.
So paint me a picture of a modern enterprise that uses IoT. I walk into my office and I'm in a telemarketing firm, right? And we're not trying to get too crazy here for other things. So so I walk in the door, doors have magnetic locks. That's an IoT device right there. I sit at my desk. What are some IoT devices that people have already but might not even think of that way?
Yeah. So let's talk about a very typical scenario that everyone is probably used to here, right? You walk into your office, you have your key fob, you connect it to your badge scanner, and it authenticates you, and you get in. Your badge has some sort of identifier, and it correlates that information and validates your identity, and therefore grants you access. As you're walking around, you're probably carrying a smartphone. Your smartphone has Bluetooth beacons. If you're in a coffee shop or perhaps even in an office, there's probably Bluetooth beacons everywhere. There are tracking your location. A lot of this could be worker health and safety type of use cases. It could be related to the fact that they want to do occupancy detection for energy consumption, for meeting rooms, and so on and so forth. And then when you sit down at your desk and you're plugging in your laptop into a docking station, perhaps there is a smart docking station that has a little touch screen and you can easily connect to Zoom. That is also an IoT endpoint. All of these things are susceptible to vulnerability. That's the key thing that it kind of keeps me up at night, is that we are relying so much on this technology to make our lives easier and easier. And in fact, it has made our lives a lot easier. But in the past 5 years, and I would argue, especially in the past 3 years post-COVID, and we've seen that as this technology is advancing and as we're getting more used to getting access to information on our fingertips and conducting remote operations and actions, there's been an increase of cyber attacks, and at a larger scale, we're talking beyond just your consumer. I think some of these, we've seen things like the Texas power grid, right? We've seen some cyber attacks on healthcare facilities. So when we talk about these endpoints, it's essentially most of the information that we interact with today in terms of physical devices is an internet connected device.
So I think that was a pretty natural segue to the discussion around security, because I think you brought that up really nicely here. What are some unique considerations when looking at securing IoT devices? And I want to try to separate the have a smart home or smart, office type of thing, which are obviously offices have higher business impacts than most homes, to like power grids, water treatment plants, and like things that are critical infrastructure, because the impact on those is obviously much more significant to a wider range of people. Are the security considerations different, or is it really just the risk is higher, but everybody should be doing the same stuff? Like, what are things to think about when you're looking at those types of devices in the workplace?
Yeah, and I'm gonna kind of slightly answer this question a little bit differently, right? And the reason why I want to kind of just take a step back here and kind of paint a holistic picture when we look at IoT cyber risk analysis. One of the biggest concerns that we have, especially in the U.S., it's a bigger deal, is that we don't have legislation around how do we procure these devices and if these devices are conforming to a particular standard, right? For instance, for internet, we know like all security goes through TLS, right? We have certain frameworks that are in place, certain guidelines that are in place. DoD has some frameworks on that. NIST has some frameworks on that. But when we talk about the physical device itself and the firmware that goes on the device, basically in the US have very little control over what comes in and what comes out. So at the core of these devices, essentially you're using a very simple or traditional microcontroller that is running very weak to no security. So when we then talk about using sensors in the industrial space or in the power space or in the spaces of critical infrastructure, what we're doing is we're working with a pool of devices that is essentially both approved for consumer space and also being used in these critical infrastructures, right? I'm talking about, for instance, if we're looking at a vibration detector, right? You want to take a look at and see if your wind turbine has excessive vibration. You find a sensor, it's MQTT capable, and you procure it, you install it, you get an SI to kind of configure all the dashboards. But the problem is, do we have a way of ensuring that these devices, if there is some sort of if there's some sort of vulnerability identified in their firmware or in their downstream processes, how do we actually take this and come up with a patching mechanism? And that's where the issue really arises. There isn't really a lot of difference between device procurement when it comes to being in a highly sensitive environment. Oftentimes when you're working with plant manufacturing engineers, you're working with folks that are down on at the plant floor, they're not concerned about cybersecurity. And for the right reasons, right? They haven't changed any of their processes in 25 plus years. All of a sudden now they're being mandated that they want to have visibility over their critical infrastructure. They have to get this done in a very short time period with a limited budget, and security naturally just doesn't come as part of this conversation. And because majority of our critical infrastructure is actually privatized, we're talking about power grids, we're talking about any of these major manufacturing plants or manufacturing plants. Because all of these are privatized, there isn't really a standard that's governing. We have to ensure that we only acquire sensors that are following these 10 guidelines outlined by DoD. There's some recommendations on that the device should have rotating passwords, it should use two-way SSL, so on and so forth. But is there a mandate that essentially forces vendors that are going out to retrofit existing infrastructure with IoT devices? Is there a mandate that prevents them from not choosing something that may be inherently unsafe? That remains to be a really big gap in our ecosystem today.
So, coming at this from a threat actor standpoint, are most threats available, or most available is the wrong word? Are most threats kind of known because there are like open source libraries and like common tools that these devices use and implement? Or would you say that most, and by the way, I'm using most as a pejorative term. I'm looking to you to qualify in some like
Mhm.
high level here. Or would you say that most things come from device specific configurations and vulnerabilities in kind of the glue code and the proprietary thing that the device is doing differently?
Yeah, that's a really good question. It's both. We've seen, when we look at sort of the trust landscape for cybersecurity just in general, one of the things that we talk about is that we should trust no one, not the device vendor, not the cloud vendor, and not the people who are configuring the software. So the large number of vulnerabilities essentially, I would say, come from the hardware chipset itself. I'll give you a quick example, and this is probably an absurd example, given that we want to maybe keep the conversation geared more towards industrial use case. But let's say it's Christmas is coming up. Your grandma's like, hey, I'm gonna get Jason this smart bulb that I saw on Temu. It's only $10 and it's pack of 4. You go online, you buy the cheapest smart bulb. It's Wi-Fi capable, it's Bluetooth, so on and so forth. Now you have it in your house. It works great. It's working fine. But tomorrow, if there's a vulnerability to it, there is no way for an average consumer, or even in the industrial space, for you to do over-the-air updates, unless if you've previously thought about that. So if I wanted to, for instance, build a bot network, right? That would probably be the easiest way. I go online, I sell a cheap sensor. This sort of classify this as a subsidized bot network cost, and it's fully functional. But at any given time, I could come in and I could take control of your network, right? And these things have happened, right? We know that there have been malicious devices that have had malicious firmware that's running, where there's very little transparency into A, what's running, and B, how do I take control of that and customize that? It's a little bit of both, right? So the first thing is, of course, the device chipset firmware and security profile of the hardware itself. But oftentimes, you're able to reverse engineer some of these things as well, given that you may be using some very advanced, sophisticated tools, right? For instance, if you have a device management platform, if you're using AWS IoT, or if you're using Cumulocity IoT, or any sort of centralized IoT platform, and if you know that I could just drop in a bin file and I could easily just install a malicious firmware on a fleet of 1,000, sensors that are deployed in a Texas power plant grid, it would be very easy for me to do that. So I think at the end of the day, there's vulnerability at each level. It's all about how do you put in the right controls in place to do risk mitigation. At the firmware level, do you have a good patch management policy? At the configuration level, do you have a way of identifying if the folks that are taking control of very sensitive operations like a firmware update or a software update, are they ensuring that they're actually privileged? Do I have audit logs of these operations? And then can I continuously monitor this entire operation and figure out if there's been any anomalies? Because what we also see is that in the IoT space, especially when it comes to IoT vulnerabilities, it's not an overnight vulnerability. It's sort of, you take control of one device, and through that you can hop onto other devices, and it stays hidden for a while until it's doomsday. And now, all your entire critical infrastructure has been consumed because there was a malware injected, and you have a complete lock of your system.
So one thing, just to kind of jump in on this, because the things you're bringing up don't sound that different than traditional system monitoring, system management, access control policies, and like that's good, right? Because it doesn't sound like these are things that people that have IoT devices, if they have even. Is it that security departments that already exist don't understand how to do these things in an IoT environment? Is it that it's not an education gap, just these tools don't necessarily align themselves to, and like examples I'll give from the little work we've done together where I've learned what MQTT was and learned about some of these standards. It feels like when I started doing research on MQTT that security was not top of mind other than MQTTS, right? Having some transport layer security. It wasn't initially meant for IoT at all. It was just a standard. I mean, I would say not meant for IoT. It was a standard for devices with power constraints. That's kind of where it started, well before we had any concept of IoT or anything. And so, what about these devices makes it harder to do? Because the things you're saying just make total sense. Somebody that hears people on this podcast talk about security every week, you're not saying anything where someone would be like, why would we do that? Very logical, but it seems like it's still a challenge. And so, what about IoT makes that a challenge to do those kind of good health type things?
Yeah, you bring in a really good point here. The short answer is that it is not very different, but people treat it very differently. And what I mean by that is that when we look at a typical IoT lifecycle, oftentimes the first conversation, with enterprises, I've worked in a lot of manufacturing facilities where all of a sudden now they want to use machine learning because they want to be able to produce their items with very low defects, and they have algorithms that they've created that could potentially make their operations really fast, or perhaps they're trying to do things like predictive analytics, very basic IoT use case. So the first step that in a typical IoT operation project is that you try to leverage what you currently have, right? So you may have, for instance, a PLC system that is in a factory floor that is an industrial protocol. Essentially, you have a bunch of sensors that talk to an existing factory floor controller, and through that you can gain access to the sensors that are already in place. So typically what you would do is you would try to get information from brownfield devices that are already there, that are not designed for the internet era, that are not designed with security in mind. These are analog devices in certain cases that get converted into a digital signal at like the factory floor level. So in typical engagement, you will come in, you'll install an agent on the PLC, which converts your analog to digital signal. And then from there, you're able to read the inputs and outputs. You're able to change actuators and things like that. And the key thing to think about in this scenario is that the personas that you're probably working with are folks that are your process engineers that know industrial analytics at a very low level. So when they're looking into designing a system, for them, cybersecurity is a very high-hanging fruit. They want to be able to quickly prove that this thing works. They've got their CEOs banging at their at their door every 2 weeks saying, "Hey, if this doesn't prove, then we're gonna have to cut the entire team or cut this project." So they're being forced to come up with these scenarios really, really quickly, and oftentimes they're trying to prove these use cases very, very quickly. And in doing so, cybersecurity is never like the first conversation, because quite frankly speaking, cybersecurity and IoT shuts down a lot of conversations. It is the truth. And for good reason, because if you were to bring cybersecurity folks in, they'd be like, well, there's no way we're going to let you approve a communication that is over HTTP, because anyone can sift the network and get this information. But, of course, if you were to come up with some sort of security model around that and prove that this communication is staying within the local network, it's not going anywhere, perhaps you could make it work. So oftentimes, when the POCs are happening, they're happening in silos to prove that this technology is going to work. And oftentimes, when they get scaled up from proof of concept to a production level workload, security considerations are oftentimes ignored because they can lead into roadblocks when it comes to deploying the solution on time. Secondly, you also have issues because you are relying on technology that is non-IP based, that oftentimes is susceptible to a lot of radio frequency related interference. So for instance, I have a Flipper Zero in my hand. I can clone an RFID tag really quickly, and I can gain access to a data center and cause a lot of havoc. It's something that I can do very, very quickly, very, very easily within 2 seconds. I were to say, okay, well, now I want a rotating UDID for all of my badges and I want to do this and that. My budget then increases. I have to increase my budget by 10x. So oftentimes, if you bring in security as a conversation for innovation in IoT, you're going to burn yourself out very, very quickly. Security oftentimes becomes as a final stamp of approval when it comes to designing a solution. And what I have seen in my example is that even though, in the example, Matt, that, you and I have worked with a lot of security accreditations for, DoD systems and, and IoT device platforms. And oftentimes what we end up doing is seeking a lot of exceptions for the patches for the areas that we have no control over. Technically, are we in compliant by 853? Absolutely. But the amount of poems that get written for these IoT devices merely because we don't have control over the hardware vendors is the reason why you see a lot of security vulnerabilities that come out of IoT projects.
So you hit on a lot of points there. So first off, I do just to kind of rephrase it. It sounds like, and this has been true in my limited experience. So it sounds like it's true in your broader experience that these devices weren't initially built to be digitally connected, or at least a majority of them, or enough of them that are in deployment today that you end up having to sidecar security. I'm imagining network isolation and other approaches, which are very much risk mitigation factors. To your point about being 853 compliant, like you can't check the actual sub-control implementation for access control because maybe the device doesn't let you have usernames or anything. You just have to connect to it with a certain port, and it's always going to be open.
Mm-hmm.
And so the only way to say that there's access control is to say, well, it's on a network that you have to do some type of pass-through authentication in order to get there. So it sounds like you've kind of painted a picture of a world where the devices that are in production today are not even able to meet best practices. And the way people deal with that is typically to handle it by managing risk versus necessarily mitigating risk. Managing risk can be we have a POAM. Managing risk can be we are well aware and we talk about it every quarter and we beat the manufacturer up at every renewal to fix these, top 5 issues. But mitigating risk, especially in a network environment, and we know this from some of the industrial controller work that we do, is very expensive. We're in the middle of working with a boiler and chiller system for a government agency that was initially set up in a way that was just very vulnerable to outside traffic. It wasn't anyone's fault. They were just trying to use the IT switching fabric that they had available to them. Having a VLAN segregation of critical, literal life support systems in this case is not enough for high assurance of lack of tampering. No one's going to change the Allen Bradley switches. They are what they are. There are modern, and that's actually something worth. I'm curious if you've seen, because for us, we kind of said, all right, well, let's come in and put in an OT software-defined network. The OT SDN solutions that are way more advanced than your traditional Allen Bradley switches, and we can upgrade all of your switches to this, and we can sub all of the network out, and we can use existing wiring and existing cable runs to do it. And the response was absolutely not. We're an Allen Bradley shop, right?
Yeah.
That's
Yeah.
just
Yeah.
we're not changing that. So
Yes.
it's to a place where the devices do what we expect them to do from a modern security standpoint, but most places aren't there. And in limited customer engagements where we've brought it up, it wasn't even like a possibility in their mind.
Yeah.
And it was maybe 30% more expensive than having us run a bunch of cable and like rejigger the network using their kind of more dated approach. Like, it was more expensive. I get budgets are real, but it
Yeah.
wasn't like 3x the cost. It was like 30% more expensive, and there was just zero interest from the customer standpoint. So I'm
Yeah.
curious if that's something that you've seen in your environments as well.
Yeah, and I would say it's not so much so even of budgets. Even if you bring in, I would even guarantee that if you brought in a solution that was effectively the same price as the Allen Bradley solution, the question that would get asked is, well, we've been doing this for the past 30 years. I don't want to change my processes, because now if I change from Adeel Bradley to, let's say, GE, and GE has this amazing new software that is secure by design and has all the industrial protocols that are built into it and provides IP-based access, and we don't have to work with 5 different vendors. We can just work with one and ensure that there's safe comms throughout the SCADA network. That is a very valid conversation, but oftentimes when you're dealing with process engineers that are literally at one point are coming from a clipboard and paper mentality where there has been no automation in place, for them, changing something to provide some unrealized benefit at the shop floor is not a compelling enough use case for them. That's why cybersecurity in industrial settings should be a top-down mandate, right? If you don't have top-down mandates around cybersecurity, then at the shop floor level, there is no compelling reason for a process engineer or a plant engineer to say, hey, or plant manager to say, hey, yeah, I'm gonna redo all my business operations. I'm gonna redo all my PLC logic, and I'm gonna have to retrain all my employees only to do what, which I don't exactly understand. So that's where the problem lies, is that they see a shiny dashboard, and that's all most IT OT shop floors want to see. And I would even argue that even if the cost was the same, you're actually paying a much lower total cost of ownership in case if there was a cyber breach, right? Because when you do have, a breach, and you have essentially your production goes down for, let's say, even a couple of hours, how much does that quantify to? So at the end of the day, I think it's about ensuring that when you're, at least when our design, our mandate at AWS essentially is that when we talk to our customers, we want to make sure that we come up with a security first design, because that essentially, if you can set some corporate standards at from a top down level, then you can just determine what your risk level or what your risk appetite is from the beginning, and that way you'll not work on solutions that are inherently unsafe. Like, for instance, if I'm using MQTT over a public network, and I'm not using any, sort of encryption or any sort of way of mitigating spoofing, then obviously that's something that would not ever be approved in any sort of critical infrastructure type of use case, right? But how do we ensure that happens? That's where the top-down strategy comes in from the C levels.
So I'm curious, because we've talked a lot about the devices and the limitations of themselves and the environments. What have cloud providers like AWS and infrastructure providers kind of brought to the table, both in terms of capability to kind of enable it, but also in terms of security?
Yeah. So one of the big challenges that we see in in IoT cybersecurity is that each vendor and each device slightly uses a different adaptation of their protocols. A temperature sensor that's using MQTT may have a very different mechanism of reporting data via MQTT versus a vibration sensors versus a physical actuator or a motor. And in the past, what has happened is that as these large number of devices are increasing, shop floors, manufacturers, they would build these point-to-point solutions to manage the infrastructure for their IoT devices. And what do I mean by that? If you have a sensor, you're building in an agent, and you're communicating directly with that sensor. Then you have a couple of sensors, then you have built another software around it. You have 5 or 6 or more. Now you basically have created this spaghetti of a network for IoT devices, where if tomorrow anything happens, you have no clue as to where the compromise happened, what your standards are, and so on and so forth. So in the past 5 years or so, I would say there has been a huge shift in ensuring that there is a standard created for onboarding and maintaining IoT devices. For instance, with AWS IoT, you have Greengrass, which can be used on the device level to ensure that the communication occurs securely from the device to to AWS, and you're consistently following that for all your devices. When I was at Cumulocity IoT, one of the things that we talked about was making sure that we have device agents for every single type of runtime. So you have a device that's running, let's say, Ubuntu, you have a device that's running Linux, you have a device that's running some sort of code. Well, let's create these agents that can then securely transfer this information over to a centralized place. And then from there, I can conduct operations in a very secure manner. If I need to SSH in, I'm not opening up ports over to the public. I'm initiating a reverse proxy session through the device agent that's handling all of that. So in the past, we've seen that standardization has become a really good way to ensure that when you're communicating with your devices to the cloud, that you have an agreed upon sort of risk tolerance and a standard for communicating. And then also, you now have tools like AWS IoT Defender that can continuously monitor the communication that's going in and out of your device, the patterns. Like, if your smart bulb is sending 30 megabits of data every hour, there's something wrong with that. There's something up. That shouldn't be happening, right? So you can then now define, your typical behavior for these devices, and you can model that behavior. And with the advent of AI, you can then very logically and very quickly determine, is your device acting the way that it's supposed to? Or is it acting the way that it has acted in the past, 2 years of its deployment? And if there's an anomaly, then oftentimes there's automatic actions that can be taken to go back to a known good state or whatever it might be.
And would you say that these kind of infrastructure surroundings are kind of unique to devices, or really more like a platform that can be used across most standards that are adopted by these, generally speaking, non-standard devices?
Come again with a question. I want to understand. I want to make sure I understand that correctly.
So I'm curious if and I'm gonna just pick a brand at random that was a good brand that you and I worked with, but is it that which Rhombit? Rhombit was the name of the company, yeah.
Yeah.
So is it that AWS has Rhombit connectors and infrastructure for Rhombit, or is it that they're very focused on MQTT and some of the standards that are ubiquitous across devices? Like, how is that infrastructure to roll back to a known good state and other things? Is it based on trying to adopt standards that kind of hit that X% mark of the market? Or is it that that everyone's kind of actively courting big name vendors and just kind of going after those stacks and platforms from an
Yeah,
infrastructure
yeah.
perspective?
You bring up a point that it's very dear to me, which is exactly around what you mentioned, which is you have these large players, right? Let's say I'm going to name like Philips Hue, for instance. It's
Sure.
really, really big name in home automation, right? Philips Hue has their own proprietary protocols, and they have their own APIs, and they can communicate with their own softwares very, very easily. And oftentimes these are closed libraries. They own sort of the IP behind that. So it's not advantageous for cloud providers or even IoT platform providers like Cumulocity IoT to work directly with hardware vendors that have their own established ecosystem. It doesn't solve any problem in the realm of cybersecurity or standardization. The area where most IoT platform vendors play in is around the commoditization of IoT protocols in a standardized manner. You have several different industrial protocols like MQTT, CAN bus, Modbus, OPC-UA. You want to quickly get that data in a secure manner from your manufacturing plant to the cloud. How do you do that? Well, deploy a Linux agent, configure the IP settings, and it'll do auto discovery, and you can then figure out exactly how the data needs to go where. Similarly, on devices that might be slightly more sophisticated, like for instance, if you're working on a smartwatch and you have, or I've worked in the EV space where I've worked with a very large auto manufacturers that want to do over-the-air firmware updates for their vehicles. Well, how do you ensure that you're able to do that in a manner where certificates are signed, the binaries that are coming in are secure? We're talking about very complex operations, right? We're talking about global operations in this case. So what happens is that platform vendors like AWS and Cumulocity and IBM and so on and so forth, they are keeping a host of essentially agents that is compatible with various runtimes. You have a container that you can deploy. Great. I can give you a Docker compose file. You drop it, configure the settings, and boom, I can get data from your local files. You need to talk to industrial protocols. Drop this agent. It'll be able to read OPC-UA. You want to do over-the-air updates for an Android library. Great. Here's an example, and using Greengrass, which is one of the software suites that AWS offers for device management on the edge. Do a Greengrass deployment, and now you can manage that holistically across your entire fleet, right? So there's been very specific software suites that have been created for very specialized use cases. If you're doing over-the-air updates, it's going to be a slightly different process than if you're doing an industrial protocol for an Allen Bradley PS.
And just so first off, it sounds like we're moving towards standardization, but there's a lot of gaps there. And I'll say from my just personal home experience in my old home before I moved, I was a Z-Wave guy. I wanted all my lights to be Z-Wave. Z-Wave friggin' sucks. It doesn't work, right? Like I have many non-technical people in my life that are just like, why did you make the light so complicated? Was like kind of the feeling that came from those people. And for me, it was like, I want to be able to, I forget to turn off lights. I want to be able to turn them off on certain intervals and times and whatever. Moved to my new place. I got Lutron, even though it's completely proprietary and it doesn't fit any of the like ideals that I have as a software and infrastructure person. It just works every time. Every
Mhm.
time you click the button, the Lutron switch works. And I'm curious if that's a similar thing when you start looking. I mean, we're talking about my house and like forgetting to turn off a light in my office, which is a waste of power, but like 60 cents worth of power a day. So we're talking
Yep.
about definitionally low impact stuff. But do you find those standardizations and proprietary fight true in like your higher end PLC industrial controller type IoT devices,
Yeah,
where the proprietary ones just work better and that's why people
all the
use them?
time. All the time. And this is where I think regulation needs to come in to ensure that the proprietary protocols that are available to the vendor themselves are, and they'll make it available. They're just not going to document it. There needs to be documentation around the utilization for these proprietary protocols, especially if you're deploying in sort of a government type of use case or in terms of a physical infrastructure type of use case. What I'll say is that I have seen that it's not so much of a reliability issue. Once you have sort of the connection established, you know, I can reliably conduct an operation, but to what degree am I able to customize that? That's really where the problem comes in. If I want to turn off a light or turn it on, that's great. But what if I'm on a wind turbine and I need to change the configuration settings to ensure that it changes the angle ever so slightly, and I want to tie that back into my weather radar system that is not from the same vendor? I may be able to turn it on and off, but I may not be able to rotate it because that is a proprietary action that is not available outside of a particular vendor platform. So that's where we see when we look at large deployable use cases, it's not so much so that okay, like I'm not effectively able to conduct operations. Sure, I think there's ways to get around it. I think you can if you enough professional services effort, you can ensure that if you send something over some sort of IP network, that it gets received and the operation gets executed. But the problem mostly lies in at what degree am I able to do that? And what happens if the API changes? Am I going to be notified? So should I potentially go down this path where I'm on my own? I have no way of notifications if something changes. I have no support from the vendor, and I can go down this path and build everything. And then tomorrow, if something changes, I'm left out on my own. So what do? I work with the vendor, and then I build everything related to the vendor system. And then now, going back to what you had said, you are now saying, and I'm loosely quoting Alan Bradley here. I'm not saying Alan Bradley does that, but now you've kind of been a product of the system, and now you're saying, hey, we're going to replace everything, and we're going to put GE in. But you're like, no, we are an Alan Bradley shop. We've struggled a lot. We've had many sensors in the past. They have not worked. I'm not going to make that happen. So now you're trying to convince this, plant engineer that switch everything from Alan Bradley to something else when they've proprietarily just designed their entire ecosystem around a particular vendor because they just wanted things to work.
Yeah, I mean that's especially in these plants. They're not general IT has to do a lot of things. So discussing trade-offs is common in that space. But manufacturing plants, in the case I mentioned, the utility plant where we're working on the boilers and chillers, like they might do 6 things, or a complicated plant might do 10 or 15 things, but they don't do an n order of multiple dozen things. A lot of them really only do one thing or only a few things. And so, how that translates is this is it has to work, right? That the function of those things is what's prized paramount. And abstract, like we're having an issue right now where we've moved people to radius security for Wi-Fi in our offices, And because we use Okta, the little Okta thing pops up and it cuts off your internet connection for a minute till you re-authenticate. Everyone hates it. We're going to fix it, but that's a trade-off in security. Providing Wi-Fi, you can't get Wi-Fi in the office. You use a guest network if you don't need local resources, or you plug into a trusted port, right? Like there are other ways to get to these general things. If you're a manufacturing facility pumping out, camera noses for drones, that's probably all you're doing. And if suddenly we have a pause in camera noses for drones, there aren't workarounds for that.
Mhm.
So that's just from a pure business perspective, I feel like that's not discussed enough, that the simplistic nature of the requirements, I feel like, drives slightly different value-based trade-offs in what does it mean to modernize? What does it mean to do security? I mean, it's just you have such a more finite target versus this nebulous, oh, we've got cloud, we've got desktops, we've got laptops. Some laptops are Windows, some laptops are Macs. It's a much more complicated ecosystem for that reason. So since we're coming up on time, I want to talk future a little bit and market trends. So where do you think both device manufacturers and people along the lines of, I mean, we mentioned Allen Bradley, we've mentioned Honeywell, we've mentioned Philips, so like you don't need to call anybody by name unless there's some good examples you wanna bring up. And what's the rest of the more general compute market like AWS looking to do to kind of play in this market long term?
Yeah. So I'm a partner solutions architect at AWS, and I think that role is quite important in the IoT space because we know that it's not just about the software, we know it's not just about the hardware, and we know it's not just about who's implementing the solution. It's an army that you essentially have to build in order for you to ensure that your systems that you are developing from an IoT or non-IoT perspective are secure. So in the past, there has been, and I think 2024 has been, a pretty good year in terms of IoT security because there has been a lot of good efforts taking place in this space. And we can take the EU and the UK as an example because their PSTI, their product security and telecommunication infrastructure regulation, introduced some standards for IoT products available to consumers. And it's essentially doing from very basic things, right? Like it's basically saying, hey, if you're deploying something, if you're a device vendor that is selling something to the consumers, that it should have unique device passwords, it should have vulnerability reporting, it should have a defined support period, it should have a framework for vulnerability patch assessment, and so on and so forth, right? And then the part that I think is important here is that there's consequences for non-compliance. So if you are a vendor that is then marketing these things in the UK and EU, and you're essentially non-compliant, there's daily fines and recalls for this. So AWS and a couple of other IoT platform providers are also working to form a consortium within the US that is essentially designed to regulate this space as a whole. We've already seen some stuff happen on a global level with things like Matter, which is a protocol that allows devices that are from different manufacturers to all sort of work together and work under the same protocol. But I think those are more on the consumer level. When it comes to things that go down more on the industrial and manufacturing perspective, and especially for DoD, there needs to be stronger play for these large ecosystem providers like AWS, like Azure, like Google, maybe small manufacturing providers, gateway providers, to ensure that there is a mechanism in place to ensure that we're getting all areas covered. And we're also ensuring that all these vendors are working together to remain secure, essentially.
And from if you had to make a prediction for the next few years of how these devices and things will shake up, we've talked a lot about regulation. I know for iPhones, that's why I'm getting a more ubiquitous charging plug and why texting with Android users is going to start to suck a lot less in the next iOS release.
Yes. Yep. Yeah.
But do you see that similar regulatory effect happening in IoT devices, primarily? I mean, we're not doing it here. We don't regulate anything here for technology unless it
Yeah.
actually kills people, and even then, it's got to do it several times. Do you think? But do you think the EU and other markets are going to drive some of these device compliance things here?
Historically, they have, right? And part of the reason why we have RCS and why we have USB-C on iPhones is because of the EU. If I were to make a prediction, I think it's gonna get a little bit worse before it gets better, particularly because the cost of sensors has gone down quite a bit. I can easily go on AliExpress, Temu, wherever, and I can, if I am, a hobbyist and I'm trying to prove something to my leaders at, power plant, it's so easy for me to use generative AI technology to go in, build some Arduino code that's using potentially vulnerable libraries and put together a POC, which is, I have seen POCs that go to production and they're just, in production without even getting stamps of approval from the production side. I mean, if you go online right now today, you can easily find so many webcams that are vulnerable that you can get live feed on. So it's already happening. We have these sensors that exist in the world out today. Some of these are guarding, critical infrastructure, and some of these are using default passwords. And I hate to say this, but I think generative AI and just AI technology has allowed bad actors to be able to work very, very quickly to essentially reverse engineer some of these things. So and we know how regulation goes. It's not there's not going to be, an executive order that gets passed that says that all IoT devices must conform to blah, 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 blah standard. That's not going to happen. It's probably going to take 2-3 years for this technology for us to really assess the risk first from generative AI and then be able to come up with a mitigation plan around that. And my prediction is that it's gonna slightly get worse before it gets better, but that doesn't mean that we're not progressing in the right step, right? I think eventually there's really good stuff that's happening all across the ecosystem. It's not being regulated because I think everybody's concerned with IoT devices specifically. A lot of reliance on being a connected world, even, especially post COVID. And, now that I can easily just automate anything, it's going to require sort of mindset shift in just in the typical consumer as well. I talk to my wife about this a lot where, I tell her to use a password manager and, all these things. And finally, I've been able to convince her to use a password manager. But one of the things she would ask me is like, I have nothing to hide. Why should I care, right? And that sort of applies to IoT as well. Like, if you're going to get a smart sensor, or if you're going to get sort of a light switch, or if you're in the industrial space and all you care about is having a cost-effective solution and you're not really doing the full diligence to ensure that your system is secure, you are potentially opening up yourself to bad actors that are highly more sophisticated now because of the use of generative AI.
I'll say that I've had the same conversation with my wife and my parents. It's definitely an interesting shift. And because these aren't consumer devices, I feel like that tail of concern is a little bit longer. Again, minus catastrophic events, right? And so we might get an executive order to improve the supply chain of critical components and critical infrastructure, but it's going to be like to make sure that we keep out Chinese counterfeits.
Yeah,
Or it's going
exactly.
to be about, like, it's not going to be like, let's get the people from NIST and the people from these manufacturers together and develop a standard for everyone to follow. I've rarely seen that happen, and when it did happen, we basically got RMF, which is good for a lot of things, but also like is interpretable and tailorable and wide enough that you vulnerabilities, park it into the middle, and say that you've been completely compliant with RMF. So that's kind of why I feel like the motivations and the fact that this stuff all kind of sits below the water line. Like, I expect when I turn my faucet, water to come on. I expect when I flip the power in my house that someone at the power company has figured out the capacity and that will work. And even when things like the Houston blackouts happened during the winter, because it wasn't a security issue, that was a capacity planning and some incredibly complicated grid understandings of when Texas decided to become its own grid. But even that hasn't fundamentally changed how Texas does its grid,
Yeah.
hasn't caused anybody to look at that and say that, we should be doing it differently, because the disruption lasted a few days. I don't think anyone died. If they did, it's tragic, but it was not enough people to raise public concern, clearly.
Yeah, and people have died, right? There have been some hospitals that have been subject to ransomware attacks, and they've had patients die because they're not able to get oxygen on time, or they're not able to get the right medication. They're
The
not able to
IoT
put
devices.
exactly. It is literally a life or death situation in certain cases. And I'll say this again: unless if you have a top-down approach, because my wife doesn't care about security, I'm pretty sure that the rest of the world is also like, well, this hasn't happened to us. The bad guys can't be after me. We haven't done anything. We're a hospital. We take care of people, right? And I think that mindset kind of has ruined security posture as a whole for organizations. And we know cybersecurity itself is an expensive effort. It does to be able to build something and say, you're going to have to re-engineer everything because, it's not, you've spent $250,000 building the solution. Great job. We're not going to approve it because it's using HTTP, not HTTPS, right? And then you start having the conversation of, okay, well, maybe I should just get an exception for it. And in certain cases, exceptions are granted, right? Because you'll have a poem that's 2 years out and, exceptions are granted. That doesn't inherently make the system less secure. It just says that, okay, I am now accepting that risk. And I think that has become sort of a problem in the DoD space, especially with IoT, because that space is not very well regulated. And DoD has not mandated anything. They only have had recommendations on IoT security. So that puts C-level executives in a very tricky situation because they don't have a mandate. They're not compelled.
Yeah. I think I understand what you mean by it's going to get worse before it gets better, because it kind of has to trigger some of those changes that kind of an appropriate amount of fear, an appropriate amount of loss, and an appropriate amount of agreement is usually what's needed to make anything change, especially at this scale.
Yep.
Well, thank you very much for joining us today. Thanks to all the listeners for tuning in. Hope to have Adeel back to talk a little bit more about IoT and other applications down the line here as we continue with This Is Fine. Thank you so much for joining us.
Thank you so much for having me.